We're going to begin Chapter 5 today. Chapter 5 is all about similarity. Similarity means that two figures have pretty much the exact same shape, but could be different sizes. If they're the same size and the same shape, that would be congruent. So we're talking about similar here, which means they're the same shape, but they're different sizes. So taking a look at these 8 figures here, which of the figures look similar? Take a couple seconds, look through them, tell me which figures look similar, and we'll go through it after you think about it. There are 2 pairs of similar figures here. One of them is the 2 hexagons, A and G. And the other one is the 2 parallelograms, E and C. So you might have thinking that D and F are also similar, but they are not. Yes, they're both triangles, but they're not the same shape triangles. F pretty much looks like a right triangle where D does not. We'll talk more about what the angles have to do in order for shapes to be similar on the next slide. So here's a definition of what similar polygons are. Similar polygons, 2 polygons are similar, and that's a new symbol for similar right here. It's just like a little tilde. So remember the congruent symbol? It's basically the top of the congruent symbol, okay? 2 polygons are similar if their corresponding angles are congruent and their corresponding sides are proportional. So that's why D and F are not similar. Their angles are not congruent. So you may have noticed we use that new symbol, like I said. Similar polygons get a little tilde. So for example, there we could say triangle ABC is similar to triangle DEF. Okay, so what does that mean? Let's have all the congruent angles and the proportional sides. Just like when we did congruent triangles, the letters match up. So we could say angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. The angles are still congruent, but in similar polygons, the sides are not congruent. They are proportional. We can write a proportion to look at the different side lengths. So what does that mean? So the ratio side AB over side DE, why did I choose AB and DE? Because those are the first 2 letters of each of them. Would be the same as the ratio as side BC divided by side EF. Why did I choose BC and EF? Because that's the second and third letters of each of them. And that would be the same as the ratio of side AC divided by side DF. Again, why did I choose that? Because that's the first and third letters of each triangle. So question 1 says, determine if the following quadrilaterals are similar. So in order for them to be similar, all the angles would have to be equivalent. All right? So we have 80 and 80. Those are equal. 105 and 105. Those are equal. 120 and 120. Those are equal. And that means that the last angles also must be equal as well. In a quadrilateral, all the angles have to add up to 360. So if we subtracted 360 minus those 3 angles, we would get 55 degrees for C and J. So the first step is making sure the angles are congruent. We got that correct. All right. So now we got to check and see if all the sides are similar. But let's write the answer for for part A here first. Angle A is congruent to angle H. Angle B is congruent to angle I. Angle D is congruent to angle K, and angle C is congruent to angle J. All right, so now let's see if all the sides are proportionate. All right. I always say either go in ascending order or descending order with the sides. So let's do ascending order here. The smallest side in the left triangle left quadrilateral is 4. The smallest side in the right quadrilateral is 8. So that reduces down to 1 over 2. So in order for this to be true, that has to happen 3 more times. All right, the next smallest side in the left quadrilateral is 5, and the right quadrilateral is 10, and that reduces down to 1 over 2. So far, so good. The third smallest side in the left quadrilateral is 6. The third smallest side in the right quadrilateral is 12. That also reduces down to 1 over 2. We're almost there. We got one more thing to check. So even if all of this is true, if the last side is not the same ratio, these would not be similar polygons. All right, so the biggest sides are 7 and 14. That also reduces down to 1 over 2. So all the angles are congruent. All the sides are proportionate. All right? So the question B actually asks us to write the proportionate sides out, the corresponding proportionate sides out. So let's do that. Just making some more room for myself here. So first we did AD over HK, and that goes with AB over HI, and that goes with BC over IJ, which goes with CD over JK. And then question C says to write a similarity statement. All right, so to do this, you can do the first quadrilateral in any order that you want. Pick any letter you want to start with. So I'm just going to write here, let's start with B. And you can either go clockwise or counterclockwise from B. I'm going to go counterclockwise. So B, A, D, C is similar. Now for the second quadrilateral, we have to match up the corresponding letters. So B goes with I, A goes with H, D goes with K, and C goes with J. So polygon BADC is similar to polygon IHKJ. And lastly, this says make a ratio of corresponding sides and simplify this ratio. So the ratio that's simplified, we already have it simplified in part B. The ratio is 1 over 2. You can write it like that. You can write it like this. Or you can write it like this. Nobody ever chooses the third way. A fraction or a ratio is the best way to do it. This ratio is called there's 2 different ways to name it. You can call it the similarity ratio, or some people like to call it the scale factor. Both of them are acceptable terms. Let's take a look at the next slide. So we are given that these polygons are similar. So what does that mean? That immediately tells you all the angles are congruent and all the sides are the same proportion, all the same ratio. So what angles are congruent? R is congruent to A, S is congruent to B, T congruent to C, U congruent to D, and V congruent to E. So part A says find the similarity ratio of these 2 polygons. All right, so we need 2 sides that match up. If you look at the polygon on the right, we only know one side length, and that side length is ST. So look up here. What side is ST proportional to? ST is the second and third letters. Over here, BC is the second and third letters. So we know our ratio is ST to BC. So I have ST highlighted. Here's BC. So our ratio of RSTUV to ABCDE is 18 to 4. Or you can write like this, 18 to 4. You always want to reduce that to lowest terms, so our answer here is 9 to 2. And again, you can write it like either of those methods that you want, okay? So I like to do this next. I like to put my numbers 2 and 9 inside my polygon, so I remember which number goes with which polygon. So now what we're going to do is we're going to write proportions. Okay, remember proportion is written like this, A over B equals C over D. So we're going to write proportions to find X and Y. Both of those proportions are going to start with the side being 2 divided by 9, or 9 divided by 2, depending on what you want to do first, okay? So let's start with our proportion 9 to 2 equals. We want to find x. X is in the 9 polygon. So when you write your proportion out, make sure x goes in the same spot 9 goes in. Since 9 was on top, x goes on top. All right, so now we got to think, what does x go with? X is on VR. VR goes with EA. EA is 3. 3 is in the 2 polygon, so 3 goes where 2 goes on the bottom. That's our proportion. Now we cross multiply. 9 times 3 equals 2 times x. Divide by 2, and we get x equals 27 over 2, or 13.5. Now we're going to do the same thing for y. Start with our proportion, 9 to 2. Our ratio, sorry, 9 to 2. Where do you see y located at? Y is right here. It's in the 9 polygon. So y plus 2 goes on the top because that's where 9 is. What does y plus 2 match up with? Well, y plus 2 is on UT. UT matches up with DC. DC is 5. And that's in the 2 polygon. So 5 goes where 2 goes in the denominator. And there's your proportion. Cross multiply. 9 times 5 is 45. 2 times y plus 2, distribute to 2, you get 2y plus 4. Subtracting 4 and dividing by 2, we get y equals 41 over 2, or 20.5. Please take a moment here, pause the video. When you're ready, try the next problem. And when you complete the next problem, come back and restart the video. Here are your answers to problem number 3. One more time, you can pause the video. The last slide is 2 more practice problems. Try those last 2 problems. And when you finish, come back and check the answers to the last 2. Here are the answers and the work to both of these last 2 problems. Feel free to pause the video and study this as long as you need. We will come back and start section 5.2 tomorrow.